In this video, we're going to look at the Riparian Denitrification Practice tool. This tool determines suitable areas for saturated buffers along the riparian analysis polygons. It also suggests areas that may be suitable with some carbon enhancement, typically introduced by wood chips. Saturated buffers work by building a lateral distribution line, usually of perforated pipe, along the riparian buffer and also a diversion gate that intercepts tile drainage. The diversion gate can be raised, and then this will in turn raise the water table within the buffer, saturating the area. And this enhances nutrient removal from the tile water. So we're in our map document. You can see I have my riparian analysis polygons here in this mint green. And let's just take a quick look at the tool interface and see what it's asking of us. So we'll go to our Riparian Assessment Toolset, and the very last tool, Riparian Denitrifying Practices. So we have about 7 inputs. It's optionally asking for our Riparian Analysis polygons, the Z factor, our Stream Reach feature class, the unfilled DEM, that'll be our new DEM, the slope roster, the G-Sergo roster, our soil profile table, and then our crop data layer land use roster. We have multiple of these provided in your ACPF geodatabase. Most likely you'll want to choose the most recent year available. We then have all of these user specified values here, starting with the minimum organic matter percent. A default value of 1.7% is provided, though this can range between 1.7 and 5.1%. The next is the minimum percent of near stream soils, that's within 20 meters of the stream, in which all soil conditions are met. And we'll go over in more detail on these soil conditions later on. Then the minimum percent of the riparian analysis polygon that must consist of slopes between 2 and 8%. We have this set to 35%, though this can range between 25 and 75. And the maximum bank height in feet, we provide a default of 8. This can range from 6 to 10 feet. Once this is all filled out, we'll get our output of the Riparian Denitrifying Practice table, or called here the Saturated Buffer table. But first, let's take a closer look at some of these inputs. So we have our wraps, our nice boxes that flow along the stream reach here with about 90 meters on either side, and they're all 250 meters long. We'll take those wraps and overlay them onto the G-Sergo roster, and we'll look for these soil conditions and see if they have been met. So 35% of that wrap area within 20 meters of the stream must have at least 1% of organic matter, that it's only 1 meter depth or shallower. There has to be less than 50% coarse material between 50 and 100 meter and 150 centimeter depth. And then the water table depth between April and June must be less than 1 meter, so we need a shallow water table. When looking at that measure from the stream, as in 20 meters from the stream, this won't work so well when we have wide rivers. So in that case, we're going to use the G-Sergo water classification and then buffer out 20 meters from that delineated area. Next, we'll look at the bank height criteria, where we've set it that it has to be less than 8 feet high. So we'll find elevations above the stream within 15 meters of the channel, and we'll make sure that 75% of all elevation values must be less than 8 feet. And this is basically to make sure that we don't have bank failure, since we're going to be saturating the area. Again, in areas where we have wide rivers, the G-Sergo water classification will be used to designate our stream reach, and that area will be buffered out to determine the bank height. Next up, we'll check out our slopes to make sure that they're all between 2 and 8%. So 35% of that riparian analysis polygon must be between 2 and 8% slopes. And finally, we'll check out our land use. It must be within agricultural land use. Alright, so now that we understand our inputs a little bit more, let's go ahead and add them and let this run. So I am going to give it my riparian analysis polygons. I have my Z factor, then the unfilled DEM is the new DEM. Other things were automatically added. Then we have to go and choose our crop data litter land use roster. I'm going to go with the most recent year I have here, that's 2015. Go ahead and add that. I'm going to keep all of these defaults here, but based on your local knowledge, feel free to adjust these. And then we see that the output table is going to the right place, and it'll be named Riparian Practice. So we'll hit OK, and let it go. Alright, so let's take a look at our results. Since our tool's finished running, we have our Riparian Practice table that's automatically been added. So we'll open up the attribute table and take a look. Here we have the percent of the polygon that, or the percent within 20 meters of the stream within the polygon that met all the soil criteria. We have the mean organic matter of the dominant map unit. We have the maximum coarse material within the dominant map unit. And we have the water table depth too within the dominant map unit of each wrap polygon. We then have some land use stats, the percent crop, percent pasture, forest, and then percent non-agricultural. We have the percent of the slope that was between 2 and 8%. We have the bank height, this was reported in centimeters. And then finally, we have whether it was suitable or not for saturated buffers. So you can see we do have quite a few opportunities for saturated buffers. Then we also provide a reason for failure. So anywhere where it says no, it will tell you. If it failed because of steep banks, so the banks were higher than 8 feet in this case, or maybe steep banks and topography, either meaning that the banks were higher than 8 feet and then the area was either too flat, less than 2% slope, or maybe too steep, being over 8% slope. And so yeah, let's join it and take a look at our results. So we'll come over to our feature class, go to join. We want to make sure that we are joining to our Riparian Practice table. And we'll again be joining by the wrap ID. So hit OK. And alright, now let's symbolize it. We'll go and open up our wrap feature class. We'll go to categories. And first, let's just look saturated buffer, hit add all values. I'm going to make ones that were successful yellow, and then I'm actually just going to make the ones that were not no color. So we'll hit OK and apply. Alright, so you can see that some of the areas tend to cluster together that are suitable for saturated buffer, which makes sense because these are largely based on soil characteristics and topography, which all of that tends to be the same the closer they are. So we get entire tributaries that are all successful and quite long lengths of stream segments that were successful for saturated buffers. And we have some areas that are unsuccessful, and if we want to know why, we can go back into our symbology and then symbolize it by reason. So we'll hit add all values. Again, the ones that were suitable I will make yellow. If it failed for steep banks, I'll make it a light pink color. If it was steep banks and topography, I'll just do a darker pink. And then if it was topography alone, let's go with a blue. So we hit OK, apply. Alright, so we see this whole segment here tend to fail because banks were too steep and a combination of topography. If we zoom in, we can even see in our hill shade, this is kind of a lower lying area, so I'm wondering if it's likely to be too flat around there. And we can see that similarly to areas that are suitable for saturated buffers, reasons for failure also tend to cluster together, which makes sense. Here's a brief recap on the Riparian Denitrification Practice tool, or better known as the saturated buffer tool.